The two technological foundations of building information modeling, parametric design tools, and interoperability, together with the growing array of BIM tools for specific functions, offer many process improvements and information enhancements within traditional design practices. These benefits span all phases of design. Some new uses and benefits of BIM have yet to be conceived, but several tracks of development have evolved far enough to demonstrate significant payoffs. Here, we consider the role and process of design from three of those viewpoints, which apply in varying degrees to different projects, depending on their level of information development. The first viewpoint addresses conceptual design, as it is commonly conceived. The importance and refocus on concept design is well articulated in Figure 5-1. Concept design determines the basic framework of the design to be developed in later stages, in terms of its massing, structure, general spatial layout, approach to environmental conditioning, and response to site and other local conditions. It is the most creative part of the design activity. It brings to bear all aspects of the project in terms of its function, costs, construction methods and materials, environmental impacts, building practices, cultural and aesthetic considerations, among others. It anticipates and considers the full range of expertise of the design team. A second viewpoint addresses the use of BIM for design and analysis of building systems. Analysis in this respect may be thought of as operations to measure the fluctuations of physical parameters that can be expected in the real building. Analysis covers many functional aspects of a building's performance, such as structural integrity, temperature control, ventilation and airflows, lighting, pedestrian circulation, acoustics, energy distribution and consumption, water supply and waste disposal, all under varied use or external loads. These simulations and assessments are carried out by the specialists on the design team, using detailed analysis models with technical input requirements. This viewpoint concerns collaboration with the various professions involved, supported by integration of the analysis software those professions utilize. They, in turn, produce the design layouts that are used to plan and coordinate the various systems. The collaborations span from late concept design through construction-level modeling. In exceptional cases involving high-level information development, the early design process can involve experimental analyses of structure, environmental controls, construction methods, use of new materials or systems, detailed analyses of user processes, or other technical aspects of a building project. In these cases, a design in need of analysis is not provided, but rather problems are defined as the design of newly conceived system components, responding to a new or more articulated set of performance requirements. The third viewpoint is the conventional BIM viewpoint of its use in developing construction-level information. Building modeling software includes placement and composition rules that can expedite the generation of standard or predefined construction documentation. This provides the option of both speeding up the process and enhancing quality. Construction modeling is a basic strength of current BIM authoring tools. Today, the primary product of this phase is construction documents, but this is changing. In the future, the building model itself will serve as the legal basis for construction documentation. This last viewpoint involves design and construction integration. At the more obvious level, this view applies to well-integrated design-build processes in conventional construction, facilitating fast, efficient construction of the building after design, or possibly in parallel with it. This phase also addresses generating input for fabrication-level modeling. In its more ambitious aspect, this view involves working out non-standard fabrication procedures, working from carefully developed detailed design models supporting what mechanical designers call design for fabrication.